I should definitely improve my Turkish also to understand the rest of the talks that we had today. I think the last talk was very much related to the topic of the Cybathlon. So I want to introduce to you this new idea of a competition where athletes with disabilities compete by using robot assistance different devices. Worldwide we have 65 million users of wheelchairs. However, they are still limited in their mobility compared to a healthy persons like me, for example, who is not in a wheelchair. So still, these wheelchair users have problems to climb stairs, for example. For example, here, it is not possible to a wheelchair user to come on the stage without external help or without adapting the facilities or adding ramps. So they are somehow limited in the mobility. Also, in nature, they might have problems to pass on uneven terrains or on natural paths. They have to go detours, and they also need increased physical effort to be mobile. So it is time to invent new technology where we can invent wheelchairs that have further functionalities. Like this wheelchair project from ETH Zurich, it is a student project where they develop wheelchairs that can climb stairs. We have 100,000 amputations per year, for example, in the USA. So there's a need to help these people by developing intelligent prostheses. For example, the Autobot C-Leg is a microprocessor controlled device which can adapt the damping properties of the prosthesis. In the picture in the middle, we have less common prosthesis, but it allows the person to climb, and also on the right side, the person that is able to walk on the mountains, for example. So there are many solutions for prosthesis. However, also these devices have still some limitations because most of the prostheses are not actuated. That means again that if you want to climb stairs, they cannot help you, they do not provide power. If you have to walk long distances, this can be very exhausting. And also a simple example, if you cannot lift or bend your knee enough, you will always hit the ground. So you need power to lift your foot. If you don't have this power, you are forced to do compensatory movements like this, which can have further problems for the user. So with the project of the Cybathlon, we wanted to connect people with disabilities with the research and development labs in order that the technology providers develop devices that can actually be used by the people. Moreover, we want to connect the people with disabilities with the general public and also the general public with the research and development labs in order that the communication is improved. To do so, we thought a very good idea would be to do a competition where such devices will be used by people with disabilities. We already tested this competition this July in Switzerland, in Zurich, and we had already some teams from all over the world which tested our idea. So with this competition, we try to provide a benchmark for the devices that the pilots, or we call them pilots in the competition, that the people with disabilities should use. We want to push the development of functional devices and also, as I said before, remove barriers between the different areas. So we started maybe 2.5 years ago, we started developing disciplines which we could use at this competition, together with the users of the devices and also experts like physicians or also technology providers. We had the requirements that the competitions need to challenge daily life tasks. They need to challenge the pilot and the technology. They need to be entertaining for the audience. All the technology has to be on board, that the pilot is completely independent from any third person. The rules should be simple, and also the scoring, and of course the whole event, the whole competition should be safe, which is quite tricky when you combine technology with people with disabilities, so we had some challenges there. We came up with 6 disciplines, which are the powered leg prosthesis race, where above knee amputees can join. We have the powered wheelchair race, where also tetraplegic pilots can compete, because all the power is coming from the wheelchair and not from the pilot. The pilot does just control the wheelchair. Then we have the powered exoskeleton race, where pilots with exosuits, paraplegic pilots compete. We have the powered arm prosthesis race, the functional electrostimulation bike race, and the brain-computer interface race. I want to quickly introduce you to the disciplines in more detail. In the powered leg prosthesis race, we explicitly challenge a task of daily life, like standing up from a sofa several times, going under or over hurdles, walking up ramps, opening a door, going backward, doing precision steps here on a stone route, going on a tilted path where it is tested how good they can lift their leg. And the last task will be the stairs, where the prosthesis user has to balance while going up and down stairs. They have to balance a cup of coffee and some apples on a base plate. Here I show you some pictures of the rehearsal from last summer. You see that in the task you really need to have prosthesis that can apply power to go up the slopes quickly, but also it needs to be controlled very precisely in order that you really hit the stones on the stone route. In the competition, we have 4 parallel tasks where 4 pilots can compete at the same time. Each pilot is starting here, and each pilot, for all the pilots, is a given time limit. So they have a certain time to solve the 6 tasks. The difficulty of the tasks is increasing from here to the end of the race. The scoring system is also linked to our requirements that we have. So first it is important to solve the task, not how fast, but just to solve it. So for example, if this pilot solves 3 tasks and this pilot solves 4, the pilot that solves 4 tasks is of course ranked better. If both pilots solve 4 tasks, the pilot that solved the more difficult task is ranked better, and in the end, time is relevant. So we really want them to solve the task, not quickly, but just solve them, because this is relevant also in daily life. The next race I introduce is the powered exoskeleton race. It is very similar to the powered leg prosthesis race. Just instead of the hurdles here, we have a slalom, because exoskeletons are a bit more bulky, I would say, than the leg prosthesis. Here we have again some pictures of the rehearsal from July. We see that commercial devices are used at the competitions, like this device from Rewalk, which is one of the best ones on the market, but also research labs that develop new prototypes are welcome to participate. Of course, the research labs have still some possibilities to adapt to the competition, whereas the commercial devices are are already more defined. So we will see who will win the race. The powered wheelchair race is also similar to those two that we have seen before. Some elements are replaced. For example, we have, instead of the stone route, we have uneven terrain, which challenges the wheelchairs more. Again, we need not only fast devices like this one here, we need versatile devices that can solve all the tasks that we have in the competitions or the tasks that we have in daily life. Powered arm prosthesis race was the most challenging to develop because the arm prosthesis users have many tricks how to solve the tasks. So they have always a solution for tasks in daily life. However, we want them to use the technology, so the sophisticated prosthesis, because if you do tricks, you might have other problems later because you do compensatory movements, which is not good for health. One task we have in the race is a general breakfast task, just preparing a meal by opening a can, by opening a jam glass or cutting bread. A very general task where the pilot is free to do whatever he wants with both hands. And we have other tasks with blue objects, and these blue objects are only allowed to be manipulated with the prosthesis in order to really challenge the technology. And of course, the control by the pilot of these devices. So as we have seen before, we challenge here different grips, also the precision grip that was mentioned before. The fifth discipline we have is the functional electrical stimulation bike race, where paraplegic patients compete. They cannot move their legs anymore because they are paralyzed. Therefore, they use electrical currents to stimulate the muscles, to make the muscles contract. And if they contract if the algorithm is very good, they contract in a nice way in order that you can propulse a bike. Functional electrical stimulation biking is used for cardiovascular training, or also maybe in the near future for improved mobility of the paraplegic patients. So here we have just two parallel tracks where two pilots compete at the same time in a race. So the challenge here is to develop optimal stimulation patterns in order that the muscles do not fatigue very early. Our body is more intelligent to stimulate the leg muscles than at the moment device that is applying current from externally. So the stimulation patterns are the critical thing in this discipline. And also, of course, the pilots needs to train as a normal athlete does to have enough muscles. Finally, we have the brain-computer interface race, where we use brain-machine or brain-computer interfaces to steer or to control an avatar in a game. So we see here 4 different avatars which are controlled by 4 different pilots. The pilot is able to send up to 3 different input signals to the avatar. If he sends the input signal in the right moment, the avatar can get an advantage. If he sends the wrong command, he gets a disadvantage. So it's very basic actually, but still, currently it's still a big challenge to do that. The idea is that you can later for example, control a wheelchair again. So tetraplegic patients can control a wheelchair, where you use maybe single commands to go faster or slower. So the teams need to develop intelligent algorithms to control the avatar in the game. And of course, the pilot needs to concentrate, because we will conduct this race in an arena where a lot of people will watch, also on TV and on a live stream in the internet. So far we have 50 teams from all over the world participating in the Cybathlon next year in October. To date we have no application from Turkey, so maybe someone of you can build a team and participate as well. Now my time is up. I would show here the new trailer of the Cybathlon, but you can also watch it online on the website. Thank you.